Welcome to another video by Dr. Carroll. This video is about software reliability. It's based off Chapter 8 of Software Measurement and Estimation by Linda M. Laird and M. Carroll Brennan. So let's start with a hypothetical scenario. Your boss says she wants 99.99% reliability when the product is deployed. How would you respond to such a question? What follow-up clarifying questions would you ask her? Good test question. We'll talk about the underlying issues in this video. When we say reliability, what does that mean? The authors of the textbook define it as software reliability is the probability that a software system will function without failure under a given environment and during a specific period of time. Let's talk about each of the different parts of this definition. Notice the definition uses the term probability and not absolutes. Okay, that's important. Next, what does without failure mean? Well, it depends on your system. For a video game, it could mean that a player cannot play or complete a game as intended. For missile guidance control, maybe it would mean being 5% off of your target. It depends. Next point to talk about is a given environment. Reliability can change based on your operating system or the object that it is controlling. If we mean all environments, we should say so. Lastly, a specific period of time. For example, are we talking about the first day of deployment or the first year? Those are very different. So let's review a couple terms. During our last lecture, we defined several terms. Faults being the defects or bugs in the system. Failures are observed faults or defects or bugs. And defect metrics measure faults, and reliability metrics measure failures. A little bit of distinction there, just to make sure we're all on the same page. So, for example, if you have a bug in your system, but it is never executed after deployment, then what will be the mean time between failure, or MTBF? It will be it will be infinity, because the bug was never executed. What about software reliability? What will it be? It would be 100%. Now, conversely, if there is only one fault in your system, but it is executed every time the system starts up, then your MTBF is 0, and your software availability is 0 as well. Last lecture was focused on faults, defects, bugs, what they are, and models of prediction. This lecture is about failures, but we'll use the more positive term of reliability to talk about them. So let's talk about severity classes for failures. Not all failures are equal. We should have different classes for different levels of failure. So failures with roughly the same impact should have the same severity class. The impact is based on cost, lost reputation, although this may be hard to measure, system capabilities, user experiences, etc., depending on what is appropriate for your organization. And an important rule is to limit the number of classes to 4 or 5. If it gets larger than that, it's hard to work with. Let's look at some failure severity examples. First, let's look at a telephone network system. Here the impact is system capability. So we have 4 severity levels, and let's talk about a description for each one of those. So the most severe level could be that the entire network is down. Okay, the impact is huge on that in terms of capability. A severity level 2 could be an entire region is down. Severity level 3 could be a single switch. And level 4 could be inconvenient operations. Okay, and there's an example of the telephone network. Now let's consider an online store. Here we will let revenue dictate the impact. Again, 4 severity levels. Severity level 1 could have a description of more than $100,000 of revenue lost, or that has that potential. That's the severity level for this software bug or defect. Severity level 2 could be an order of magnitude less, 10,000 to 100,000 in revenue lost. Severity level 3, an order of magnitude smaller, $1,000 to $10,000 of revenue lost. And then severity level 4 is less than $1,000 of revenue lost. Now let's talk about failure intensity. When we talk about failures, we now use the metric of failures per unit. For example, you're a cell phone company. It could be days or seconds until a dropped call. Okay, and so we are focused on the failures per unit and not necessarily per time frame. Lastly, let's talk about the cost of improving reliability. Management naturally wants very high software reliability, but what does it cost? If you estimate a project would cost $1 million with a failure impact class of moderate but easily recoverable losses, the same project with the failure impact class of risk to human life could cost $1.25 million, or 25% more. It's hard to isolate the causes of reliability in a repeatable fashion, but the general consensus is that there is an exponential relationship between the cost and improved reliability. For example, it may cost just as much to go from 99.0% reliability to 99.9% reliability as it does to go from 99.9 to go to 99.99%, holding all other factors constant. And engineering rule is that to add 25% more effort to achieve a highly reliable system, not necessarily an ultra high reliable system. And also you can reduce effort by 20% for a don't care reliable system. That's what I have for this video for software reliability. Thank you.